Hey guys, today we're going to talk about finding slope, and this goes with lessons 3.18 and 3.19. Just a little review as we get started. Remember that if a line is going in the downward direction from left to right, it has a slope that's negative. If it's a horizontal line, it has no slope, or the slope is 0. If it's going in the upward direction, it's climbing, then that means that it has a positive slope. And if it's vertically up and down, then that means that the slope is undefined. Let's first get started with rise over run, and I feel like everyone probably remembers that a little bit, or if you have at least heard of that. And what that means is when you go from one point to another, we have to go from left to right, and to get there we have to rise and then run. So this 9 and 8, what they come from is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I had to rise 9, and I went over 1, 2, 3, 4, 5, 6, 7, 8. So my slope is 9 over 8. Let's take a look at these examples. So for this first one, the hardest part is finding where we're going to put our point or our coordinate. Let's go ahead with this area here. And then down here. Well, it doesn't like that place. There we go. Okay. So our rise over run, it doesn't mean that you have to go up. So for in this case, I'm going to have to go down. I'm going to have to go down and then over. So let's see here. I'm going to go down 1, 2, 3, 4, 5, 6. And then I'm going to go over 1, 2, 3, 4, 5. So this has a slope that we went down -6 and then we went over 5. So it has a slope of -6 over 5. Another example, we have this point here and there. So we're going to go up and then over. So we had to go up 1, 2, and over 1, 2, 3, 4, 5, 6, 7, 8. So it has a slope of 2 over 8, and I can reduce that down to 1 over 4. Notice the difference in these two lines. One is going down, so it has a negative slope, and the other is going up, so it has a positive slope. Now sometimes you're going to get examples, or you're going to get problems where they don't have a graph for you, and you need to be able to find the slope given the 2 points. So that's when we want to use the slope formula. And that would be our y2 minus y1, and then x2 minus x1. And what those numbers mean are the 2 different points. So let's look at this example down here. So we have an x and a y for our first point, and an x and a y for our second point. And just like that, we have our first point, so this would be the x1, y1, and the other would be the x2, y2. The hardest part is labeling those. Then all we do is we plug it into our formula right up here. So the formula says y2, so for our example, our y2 was 5. And then we have our y1, which was 4. Then we have x2, which is a -3, minus my x1, which is a 2. So I have 5 minus 4, which is 1. And then -3 minus 2 gives me a -5. And I want to clean it up a little bit, making it -1 over 5. Let's look at some more examples. Let's go with the 4, -3, and the 2, 5. Again, we want to just label our points. So we have our x1, y1, x2, y2. And remember, our formula says to do y2 minus y1 and then x2 minus x1. So plugging straight in, I have my y2, which is 5, my y1, which is a -3, my x2, which is a 2, my x1 is a 4. These two negatives up top are going to become a positive, so I have 5 plus 3, which is 8, and then 2 minus 4 is going to be a -2. So when I reduce those down, the 8 divided by -2 will be a -4. Let's look at the next example. We have 5, 7, and then -3, -2. We want to go ahead and label our points, so x1, y1, and then our x2, y2. Plugging straight into the formula, I have y2, which is a -2, minus my y1, which is a 7, my x2, which is a -3, and my x1, which is a 5. So I have -2 minus 7, which is going to give me a -9, and a -3 minus 5, which gives me a -8. Those two negatives become a positive, leaving me with 9/8. Let's talk about the slopes of parallel and perpendicular lines. The first one is the parallel lines. And parallel lines are lines that never cross. We know that. So if they never cross, that means that they're going in the same path, okay? So they have to have the same slope. So let's take these two lines for instance. Let's say that slope A has a slope, line A has a slope of 3/4. That means that it's going up 3/4, up 3/4. That means that line B has to have the same slope, which would be 3/4. Up 3/4, up 3/4. The way that I like to remember that is it'd be like two planes flying in the same path. Another set of lines is perpendicular lines. And basically, their slopes have to be the complete opposite. So for instance, with the horizontal line, it has a slope of 0, but then a line that's going straight up and down, that'll have a slope that's undefined. So we want their slopes to be the complete opposite. And what that's called is those lines have they have slopes that are opposite reciprocals. So for this example here, it has a slope of 2/3, and then it switches down to -3/2. So what we're going to do is we're going to change the sign. And what I mean by that is we're going to go from positive to negative or negative to positive. And then we're going to flip the fraction. So it says, what is the slope of the line perpendicular to? Okay, so if we have a slope that's -1/2, we're going to first change our sign, so it's going to go from negative to positive, and then our fraction, 1/2, will flip around to be 2/1. So whenever I clean that up a bit, I don't have to write the positive sign, and I also don't have to write the 1 under the 2, so the slope would just be 2. Okay, the next one would be 8/7, so it's going to go from positive to negative, and then flipping my fraction would be 7/8, so it would have a slope of -7/8. C, we're going to go from positive to negative, and flipping the fraction makes it 5/3. And the last one, negative, goes to a positive, and 11/7 after we flip the fraction. Cleaning that up a bit, all I'm going to say is 11/7. Now, the mid-segment of the lines, basically that's just the middle point, or the middle place, okay? And you see here, here's the formula for it. A really simple formula. Another way to think about that is it's the average of the 2 points. So in this case, we're going to take my x's, x1 and x2. So that would be, for this example here, we'd have the x1, y1, and then we'd have x2, y2. So using our formula, my x1 is going to be a 1. My x2 that I labeled up there is a 6. And I want to divide that by 2. And then same thing for my y's. I have my y1, which is a 2, plus my y2, which is a 4, and then divided by 2. So for us here, you have 1 plus 6 is 7, and then 7 divided by 2 would be 3.5. And then my y value would be 2 plus 4, which is 6, and then 6 divided by 2, which is 3. So roughly on the graph, my midpoint would be right about here with the 3.53. Okay, this example says determine whether the segments or lines are parallel, perpendicular, or neither. Okay, remember that parallel lines have equal slopes and perpendicular lines have they have the opposite reciprocals. So our one segment has endpoints of 4, 8 and 6, 3. Using that formula, the slope of a line is y2 minus y1. So let me go ahead and label my points here. So my y2 would be 3, my y1 would be 8, my x2 is 6, and my x1 is 4, making the first line have a slope of negative 5 over 2. Now my next line, I have a negative 1 over 5 and a negative 6 over 3. Doing the same thing that I did before, my y2 is a 3, my y1 is a 5, my x2 is a negative 6, and my x1 is a negative 1. So I have 3 minus 5, giving me a negative 2. And then I have, so I have negative 6 minus a negative 1. So these are going to become a positive. So I have negative 6 plus 1, giving me a 5. Giving me a negative 5. And so these two negatives would become a positive. So it's really like just saying 2 over 5. So my slopes would be negative 5 over 2 and then a positive 2 over 5. Now, they are not parallel because they're not equal, but did I change the sign and flip the fraction to get the new slope? Yes. So that means that these lines are perpendicular. We have time for one more example. What is the slope of a line that is perpendicular to the coordinates of x are negative 2, 1, and the coordinates of y are 1, negative 3. So I have the negative 2, 1, and the 1, negative 3. So I need to find the slope of those. So it'd be negative 3 minus 1, and then 1 minus a negative 2. So this would be a negative 4 over 3. And remember, for the lines to be perpendicular, we have to change our sign. So it's going to go from negative to positive, and then I want to flip my fraction, making it 3 over 4. So if a line were to be perpendicular to the coordinates given to us at the very beginning, it must have a slope of 3 over 4.